Hi, my scholars. This is my school channel and my name is Abiola. For this video lesson, we are going to walk through the topic statistics. Of course, we are going to consider several things that are pertained, right, regarding statistics. So at first, we are going to kick off with representation of data. So right there, we are going to look into what we have. We are going to talk about bar charts, or you can refer to it as bar graph. We can also talk about histogram, pie charts. Those are the graphical representation of data. So we have the tabular representation. So much more are loaded in this video. So you don't want to go anywhere because you have to stay with us, and we will be right back. You're warmly welcome back to the My School YouTube channel. So right there we have slides prepared for this video lesson. So we are going to kick off with the definition of statistics. So how do we define statistics? Basically we can just say this is a branch of mathematics that deals with the collection, organization, presentation, analysis, and interpretation of data. So you want to collect data, you want to organize it in a way whereby you can access it, and also the way you can present it. All of this is basically for you to be able to access the information or package it properly, to look presentable. Then you want to analyze it, because the data is so not useful, when you just package it. You've collected it, you've packaged it, but you are not able to analyze it, because the reason for analysis is for you to interpret it so that you can derive useful information or whatever thing you want to do with the data. So basically, this is what statistics entails. So go ahead to the next slide. So what are the types of statistics? We have the descriptive statistics and the inferential statistics. So basically, under the descriptive statistics, we have the measure of center of tendency. Some we call this measure of location. That's where you have your mean, median, your mode, right? Then we have measure of variability or measure of dispersion. Okay, right there you have your range, your variance, your dispersion, your standard deviation, and the like. So let's move ahead to the next slide. So still we are just going to look at some diggings, right, into descriptive and inferential statistics. So under descriptive statistics, like I mentioned earlier, we have the measure of center of tendency, of location, if you want to put, or measure of dispersion. So under this, we have your mean, your median, your mode. Then this, we have your range, your standard deviation, your variance, your absolute deviation. Okay, so then we have for the inferential statistics, we have the hypothesis testing, then we have the regression analysis. Here we have the z-test, the f-test, the t-test, linear regression, right? So I'm just trying to give us a general overview of what we have. Yes, we'll go to the next slide. So what do we use the descriptive and inferential statistics for? So the descriptive, we have to organize. You want to organize your data, you want to summarize it. You have such a large amount of data, you want to summarize it. Then you want to simplify it, right? Then you want to describe and present the data. So that is where descriptive analysis, from the word descriptive, describe. So we have inferential statistics, right here. You want to generalize from samples to population. There is a difference between a sample to population. There's a difference between sample and population, okay? So of course we have another reason or another usefulness is hypothesis testing. Then we have to make predictions, general predictions. Yes, we move ahead to the next slide. So basically, looking at the types of statistics, the descriptive and inferential, this is just for emphasis for us to get relatable with these terms, right? So we have, it's actually methods for organizing and summarizing information. At first we mentioned statistics about collecting data, organizing it, presenting it, analyzing it, then interpreting it. So we have this. So this method consists of tables, your charts, your graphs, calculations such as averages and percentages. So that is where descriptive statistics come in, right? Then we have inferential statistics. Right here you want to do estimation, you want to do prediction, right? Or generalization from your samples to a total population, So I think these are very good outlines for us to take note of. We move ahead onto the next slide. So, we've been talking about data. Data is like the bedrock or the cell of statistics. So what is data? Data is a plural word and a singular form is datum, right? So datum is a Latin word meaning something given. So it can be in form of numbers, characters, it can be symbols, it can be images, etc. Okay, which can be processed by computer, or if you want to do it manually, depending on the size of data that you have with you. So data is basically a collection of facts that is made up of text, numbers, dates, etc. So you can see examples here. We have Murray, we have 35,000, we have, this is a date, of course. So any raw collection of facts and figures which is not meaningful to the user is called data. So it's not yet processed, it's not yet packaged to put. So that's, of course, is data, singular datum. So move right to the next slide. So what are the types of data? So we have the variable data and we have the attribute data. Of course, this is a kind of type that we can find, in some articles. So for variable data, we are looking at something like product characteristics that can be measured. Under variable data, we have the discrete and the continuous. So of course, we are going to deal with that as we move ahead in this video. So examples like your length, your size, your weight, your height, time, velocity. Then we have the attributes data. Okay, so these product characteristics evaluated with a discrete choice like good or bad, yes or no, etc. So move ahead to the next slide. So you can see data, we have the quantitative data and the qualitative data. So for the quantitative data, you can see we can attach a variable numerical value. Then we have qualitative, we are looking at categorical value, right? Or categorical system. So you can see for the quantitative data, like I mentioned earlier under variables, we have the discrete and the continuous. So what do I mean something is discrete? You can actually attach an exact value to it. It can be counted. And then for continuous, you are looking at something that you just have, like an estimate or something like that. And right here, you have to measure it. So this is counted, this is measured. Instance your temperature. Okay, so let's come to the qualitative aspect or kind of data. You can see we have your binary and your multiple. So under multiple, we have the nominal and ordinal. So ordinal means there is an order, right? So there is a ranking, there is a scale, something like that. Then for nominal, you look at something like probably sex. There is no ordering per se, like the sex of your demographic, and things like that. So basically the sex, the gender, or sex, gender, okay, we actually use them interchangeably. So that is what we are basically looking at. So order is not imputed here. Order, scaling, rank, this is where we find it under ordinal kind of data. So move ahead to the next slide. Yes, so we can represent data or statistics, in two ways, right? We have the tabular representation and we have the graphical representation. So this is just a compilation to put. So we have the bar graphs, right? We have the histogram, we have the frequency table. So the frequency table, I can actually push it under the tabular representation or representation of data. So we have the frequency table, we have the cumulative frequency table, of course, right? So we have the circle graph. You can refer to this as your pie chart, right? Or your divided circle. We have your line graphs, we have your stem and leaf plots. You can see this, right? We have your box and whisker plots, we have your line plot. These are ways whereby we can actually present our data. Let's move on to the next slide. So, like I mentioned earlier, we can actually use graph to represent our data or present our data, and we can actually use tables. So when it comes to bar charts is an example, right, of your graphical representation or presentation of data. So you can refer to this as your bar charts, bar graph, whatever thing your textbook or your source, right, calls it. So we have a bar chart represents a data set, right, by using vertical and horizontal bars. So this is vertical, you can see, okay, these are vertical bars to put, right? Sometimes so the bars can just be attached to the side. Okay, of course we are going to dig into that as we move further in the video. So the larger the bar, the higher the value, for the individual category. So you can see this is class 3G's favorite pet animals, then you have favorite pets, right? So you can see to draw a bar chart you need the following. So at first you need a pair of axes, your y-axis and your x-axis, right? Usually the horizontal axis is labeled with category of the data sets. You can see, okay, then, and the vertical axis is the frequency axis or your y-axis, okay, to put. So your axis must be labeled, and of course your graph should have a title, so you can see the title of this particular graph. Of course we are going to look at the part of a bar chart. All right, so your axis must be labeled. Then we have secondly The frequencies need to be labeled on the vertical axis in equal intervals. So you can see the frequencies, they are labeled, right? Equal intervals. So you can see the interval here is actually 2, 0 to 2, 2 to 4, 4 to 6, 6 to 8, like that. Okay, so we have the bars need to have equal gaps between them as it is representing discrete data. You know, discrete data is counted, so you can see it, or they are counted. So you can see that the spaces between these graphs, right, they are equal, they are the same thing, right? So the bars need to be of equal width, very important. So the size of this graph, the size of this, like the width, right, they are actually the same. The spaces between them, they are the same as well. So these are unique features, you know, regarding bar charts. So we have the chart needs a title, which I've mentioned earlier. Of course, let's proceed with our slides. Yeah, so what are the parts of a bar graph? So like I said earlier, you can call it your bar graph, your bar chart, whatever thing that is applicable. So at first we have titles. So use keywords to tell what the graph is about. So probably an examiner or a user comes across your graph, your bar graph, you know, they want to see, okay, from a glance, okay, what is this graph all about? Okay, so this is actually the title. So the title of this graph is Unit 1 Test Results. Okay, then you can see we have your bars. This represents the amount of data for each group. So these are your bars. These are actually vertical bars. So you can see your bars. Okay, then you have scale, shows the units used on the x-axis. So you can see the interval here is 0 to 5 is actually 5, right? So this is where you have your frequency. Then you have your labels. Okay, so you explain what kind of data is shown on the x and y axis. These are just emphasis, right? Let's move right to the next slide. So we have different types of bar graphs or bar charts. So we have the simple bar graph. Okay, so what are the properties that we should do? This is just the foundation for every kind of graph that you'll be pulling up, bar graph that you'll be pulling up. So the properties, no one, okay, they should have horizontal and vertical bars, right? Okay, it can be presented in the form of vertical bars like this or horizontal. Of course, I'm going to use pictures to show us an example of horizontal bars. All right, they can have spacing between the bars, which is very proper, you know, for bar graphs. You know, this is one unique feature that makes it different from your histogram. You know, there should be spaces between the bars, and the bars must be the same width. Okay, from year to year, from year to year, from year to year, from year to year. They're actually the same thing. All right, they must start at a frequency of 0. Do you see? Those are unique features. So let's move on to the kinds of bar graph or bar charts that we have. All right, so this is still a general kind of review of what we mentioned earlier regarding graphical representation, you know, of data. So we have histogram, you can say histogram here. All right, then we have your bar graphs. Okay, we have your box whisker plots, right? We have your spaghetti plots, we have your pictogram, right? Then we have your pie chart. So this is just a review of the graphical representation or presentation of data. So let's go back to our bar graphs. So what are the types of bar graphs that we have, or bar charts, if that is what you want to call it, right? So we have the vertical bar chart, so you can see they are sitting like this, all right? Then you have the horizontal, so you can see they are sitting like this. It's just like a flip side of what you have. Then you have the double bar chart. Of course, this can carry another name for other kinds of sources, right? So you can see this double, okay? You can see, then these are your keys. Of course, they are very important. You can see cylindrical bar chart. These are actually improvements or variations to expression. So instead of having something that is like rectangular, you have it in cylindrical form. Then you have this 3D bar chart. Of course, we still have some variations that we can look at on the next slide. So you can see we have the types of bar charts. This is, of course, the vertical. I think we can actually identify this very well. You can see the title of the graph. Okay, we have the horizontal. So you can see right here we have our title, our x-axis here. Right here, you can see it has now been moved to this place. Just a switch, right? So it's facing like this. Then you have your stacked bar graph. So you can see they are being stacked. More than one particular kind of data is being packaged on a single rectangle. So you can see each rectangle carries just more than one representation. So you can see this. So you can see this, you can see this. So these colors tells you, these are variations that are available, right? They are being stacked on each other, just like the name implies. Then we have the group bar graph. So you can see the name it was called earlier on the previous slide that we saw. So you can see them, right? They're being packed together. Packed together. Of course, their width are actually the same thing. The spaces or the distance between each bars, right, or the bars packed together, they still remain the same. So these are the kinds of or types of bar graph that you may encounter or may need to use. The next slide. So we go to histogram. Histogram. So histogram is actually a graphical representation of data arranged into discrete groups. All right, so although it is similar in appearance to your bar graph, but histogram deals with continuous data. All right, do you see that now? So one distinct difference that you can actually, or one distinction to put properly, that we can see regarding histogram in comparison to your bar graph or your bar chart is the fact that the bars, you can see, they're actually packed together, no space in between. So that is one unique feature that you can use to identify your histogram. Move on to the next slide. So you can see there's a comparison between histogram and bar chart or your bar graph. Of course, as we move ahead in the video, there are a lot of examples that we have prepared, and much more explanations will be done, right? So these are just an introductory, this is an introductory thing we are doing right here. So we have your histogram, we have your bar chart. So you can see no gaps, no space between the bars. You can see there are space, and the spaces, they're actually of the same size, okay, or the same measurements. So you can see number ranges, we have categories, right? So we have your histogram, this is your bar chart. Of course, we'll move right to the next slide. So more on the differences between bar graph and histogram. So you can see this, right? So you can see this as well. Max obtained, you have your class. So in bar graph, the bars, they have equal space, like I mentioned earlier, right? So the bars are fixed, right? Like they are joined together. On the y-axis, we have the numbers. On the x-axis, we have the data, which can be anything. So we have the number, right? Which usually your frequency. Then you see this. This can be anything that will, the data that we're going to impute here. So on the y-axis, we have the numbers, right? And on the x-axis, we have the data, which is continuous and will always be number. So we can see another sample, another view to their differences. Okay, move on to the next slide. So just to wrap things up around the bar chart and histogram, you know, the similarity between them. So we just have to look into it together. So we have, for bar charts, the graphical representation of data for comparing two different variables. This is actually a representation for a single continuous data, right? So it represents categorical data. This represents quantitative data, you know, qualitative, quantitative. Okay, so we have spaces are present between the bars. This is unique. This is a very unique difference that you can note. No space between the bars. So elements get treated as an individual unit. So each bars, you can see them, you treat them as individuals. So we have grouped element gets considered as ranges. So you actually make them feature in ranges. So like from 10 to 12, you know, 13 to 15, something like that. Then the bars are of equal width. You can see the bars are on equal width. It's not necessarily that the bars will actually have equal width, depending on the value they are representing or whatever the question or presentation requires. The next slide. So we have another kind of graphical representation or presentation of data. And here we have the frequency polygon. So the frequency polygon is a graph that displays the data by using lines, okay, that connect points plotted from the frequencies at the midpoint of the classes. So you can see this. These are the classes, midpoint of the classes, and this is on a histogram, of course. Of course, you can actually draw your frequency polygon without using histogram, but it is actually good like this. Okay, this is also applicable. So plotted for the frequency at the midpoint of the classes. Now the frequencies are represented by the height of the point. So the height of the point tells you, oh, this is where the frequency is, right? So you can see that from the diagram right here. So for you to actually join or pull out your line graph, right, it's going to be the midpoint of each bars, right? So the midpoint, you can refer to these as your class mark. So you can see it right here. So the midpoint of the classes. So these are your classes. The midpoint, you join them together, okay, using lines. So it's like line segments, right? Okay, and of course, there's another unique feature. You can see that it actually begins with 0 and ends on 0, right? So you just have to close it. So this is another unique feature that separates it from your Ogive. So these are, of course, drawn frequency against whatever thing you are working with. Why for Ogive, your Ogive is cumulative frequency, right, against what you are given, right? So, of course, we are going to consider Ogive against frequency polygon. Let's move on to the next slide. Yes, so still on frequency polygon, just for emphasis, a frequency polygon is a line graph. So take note of it, it's just a line, a straight line graph. Not a straight line, but it's a line graph, okay, in which the points are joined by straight line. Okay, that's why I said straight line, they are not curves, right? They are not smooth curves, okay, by straight line and close to make a polygon. So you actually close them to make them land back at 0. Okay, that's one unique feature. So this indicates the spread and skewness of your distribution. So it's basically a straight line, that cuts across the midpoint of your bars, right, or the classes. Then you make it begin on 0 and ends on 0. So move ahead to the next content on our slide. So we now have the Ogive graph. So like I mentioned earlier, the Ogive, you can refer to it as your cumulative frequency graph, right, or your cumulative frequency curve. That's another name for your Ogive, right? So when you are drawing your frequency polygon, or you can refer to it as your cumulative frequency polygon. So when you are drawing your frequency polygon, it's actually frequency on your vertical axis against what you have here, right? But for your Ogive, it's cumulative frequency against what you have right here. So that's another unique difference. So at first, you have to find your cumulative frequency for each class. So that is one thing you need to do, right? So how do you find your cumulative frequency? Of course, we have better examples for us to be able to do that properly and effectively. So number 2, you draw the X and Y axis. You label the X axis with the boundaries. So right here, you use boundaries. So what is class boundary? What is class mark? What is class interval? What is class limit? Of course, all of those things will be properly sorted out, okay? Then we have your Y axis as your cumulative frequency. Then you plot your cumulative frequency. You connect the adjacent points with the line segments. Okay, so of course, your Ogive is actually a smooth curve. It is not a line segment like your frequency polygon. So right here, you can see that we have so much more that we have packaged in this video lesson. This is, of course, a very brief summary or a summary of what we are going to do, right, in the full video lesson. So do not forget that you just have to hit the subscription button by clicking on the link in the description below. This is going to take you to the My School website. Right there, you get to subscribe for the full package. So, and don't forget that you need to hit that like button for us. Also click on the subscribe button and always tap on bell notification for you to get informed immediately we upload the next video lesson just for you.